This here is the Silverstone CS382 NAS case. It comes with 8 hot swappable bays, and I'm going to be doing a review of this as I build up a NAS with the components that you see here. Now, first and foremost, let's take a look at the motherboards. And I have a decision to make here between the Asrock Z690M PG Riptide D5 as well as the Asus Prime B760M AAX motherboard. Now, the dilemma here is because this board costs $60 more than this board. So the difference is that you get 6 SATA ports in here as well as 4 PCIe slots. Now those 4 PCIe slots are 16X, 4X, and 2 1X. And if you see here, you can see they're 16X, which is a PCIe 4.0, PCIe 4.0 16X, but it runs at 4X mode, and then 2 of the PCIe 4.0 16X slots, but it runs in 1X mode. So you get a 16X, a 4X, and 2 1X slots, and 6 SATA ports. Now this motherboard here, it has 3 PCIe slots. One is a PCIe 5.0x16, one is a PCIe 4.0x16, although it only runs at 4.0 speed, I believe. Then the PCIe 3.0 1X slot, which is right here. And it only has 4 onboard SATA ports. So that's really the difference there. Now because this has 8 bays on it, and likely just going to use the 8 hard drives in here, I'm going to have to use a add-in card anyways, like an SAS LSI adapter. So the onboard SATA ports aren't really that important, but it's good to have the added expansion if you want it. So in the end, I'm still going to make that decision. You'll see later in this video which one to go with. I'm probably going to go with this guy here though. Now these boards do support the Intel Core i3, i5, a7, 12th, 13th, and 14th gen CPUs, and I opted for this i3 14100 LGA 1700 socket CPU here. It's only a 4-core, 4-thread CPU, but for basic NAS use, you don't need a whole lot, unless you obviously want to add additional VMs, Docker containers, or what have you to do more heavy lifting. Then you probably want a little bit more powerful CPU. But for basic work, this is probably more than sufficient. So as far as RAM, it does support DDR5, and I got these Crucial Pro series 2 by 16 gigabyte for 32 gigabytes total, and each of these boards can support up to 4 slots for DDR, so I'm just going to go with the 2 for now. And then as far as the boot drive, an M.2, the WD Blue SN580 1 terabyte SSD. As far as power supply is concerned, I've got this Seasonic Focus GX650, but I also have a Leadex 3 Gold by Superflower, and you may not have heard of that name brand, but they apparently make power supplies for other manufacturers as well. It's just that they managed to put out their own line as well. So they're both 80 plus gold. I'm going to do a little bit more research on these and see which one I'm going to go with. I may go with the 550 watt because I don't need that much power in this system, and they are both fully modular, and so we'll see where that goes from there. Before we get building, let's take a look at the case itself. This is the Silverstone CS382, and as mentioned, is an 8-bay hot swappable NAS case. Now, full disclosure here, I did reach out to Silverstone, and they provided me with a sample free of charge. So many thanks to Silverstone for that. Now, that being said, I will still give my unbiased opinion about this case. And this is my first time actually looking at this case myself too. I just got it out of the box, so first time me seeing everything here as we go through this. And as shown here, we've got this front panel here, and it opens up real easily. It's made out of plastic and has some sort of filter on the inside here. It's got 8 removable trays. And then if we look at the front panel here, it's kind of hard to see probably. We have a power button, reset button, looks like an 1/8 inch headphone microphone jack, USB-C port, and 2 USB 2.0 type A ports. Slight correction here, these are actually USB 3.0 ports. Look at the cables here, and you can see that that is a USB 3 header right there. We got this little guy here, which I'm not sure what it's for yet, but we'll take a look. Now clearly on this side it's just a side panel. We'll go ahead and remove the screws on there. Now the front panel does have a magnet on it, so when you go to close it, it secures it pretty well. Okay, so I spent a few minutes looking at the manual. I know who does that, right? But I kind of wanted to get an idea for some of the features on here, so make sure I don't miss anything. And when we open this guy up, and this front panel actually can come off. And if you look closely here, there is a little, I don't know, call it a button or whatever, and it says just push in and then pull down. I wasn't sure how this worked initially, so when I did this, like this, I let go of this, and this thing has a spring in it and just flung out, and so I had to figure out how to get that back in there, but it easily went back into place. This little spring mechanism with this little plastic part right here. Now looking at a couple other options here that I missed. These are LED power and drive. This little guy here that I showed earlier, I wasn't sure what it was. This is for a slim optical drive, so like a slim Blu-ray or DVD burner player, whatever you want to. Seems kind of odd for 2024 to include this, but I guess it is what it is. And then you have the 5¼ inch bay up here as well. Now taking a look back over here, this is clearly the back side of where the motherboard is going to be, so all your wire routing and stuff can come back here. So we have a couple of pass-throughs over here. Let me move the camera. So you can see you have a couple of pass-throughs right here that you can pass wires through. And then this little guy here removes, and this is where you mount 2½ inch hard drives SSDs to. See, just mount it right there. There's screw holes in the back that line up. And then just mount it there, and then you can route your wires that way. And it just tabs into the slot in the back here. It just uses a single screw right here. Just like that. Now if we turn this around, right, so take a look at the other side here. It has a couple of thumb screws just like the other side. You have ventilation over here. So here's the backplane that holds your motherboard, either a micro ATX or an ITX. And then pass-through wire holes for your power supply, which goes underneath this bracket here. And then if you take a closer look at the back here, we've got 1, 2, 3, 4, 5 PCIe brackets, and then a looks like a 140mm fan. Oh, that's a 120mm fan. And then you look up top over here. You can see here, this is the 5¼ inch drive bay. Now if we take a look at the drive cage here, which is a major selling point of this case, I think. It comes with the 8 hot swappable drive bays, so it has a back plane in there where you can just slide in your hard drives into. And it looks like it's powered by a SATA power and a 4-pin Molex connector, and it looks like another one down here, so 2 sets of those. I'm assuming that this one supplies power to these 4 and this one supplies power to these 4. And so you've got the 8, 1, 2, 3, 4, 5, 6, 7, 8 SATA connectors there as well for the data. Now if we go down to the bottom of the drive cage here, you can see here that there's this opening here, and it does actually have holes on the side to mount a hard drive. So I don't know if you can see that. I can't really get that in there. But it does have holes on the side to mount a 3½ inch hard drive. So you can actually get the 8 here plus an additional one here, and even you can do one up in the top 5¼ inch drive bay there for a total of 10 hard drives. Now, there's also this opening here, which I'm not sure what exactly that is for. It seems like it has some sort of opening there, and it seems like you could somehow actually mount another drive there if you really wanted to. Now once we flip this guy upside down, you can see we have the 4 screws here for the extra 3½ inch hard drive underneath here for that bracket, and also the filter here, which you just lift up on this guy, slide it out, push it back in for easy insertion and removal. That's kind of nice. It's got the 4 rubber feet here too. Now I'm going to go ahead and pull out all these brackets so we can take a look inside at the back plane. So here's a quick look at the back plane. You can see all 8 SATA ports there. It looks like they are actually SAS connectors. I will go ahead and use a LSI PCIe SAS to SATA adapter and see if I can actually run some SAS drives in there. And so here's a closer look at those connectors. It looks like it's going to get good airflow because half that is open to the fans as well. Alright, so now these are the components that I opted for. I decided to go with the Z690MPG Riptide D5 by Asrock, mainly because of cost. $60 cheaper, and I don't really need the added expansion slot or the SATA ports. Then of course I've got the Intel Core i3-14100, the Crucial Pro Series 32GB DDR5 kit, the WD Blue SN580 1TB NVMe SSD, and for the power supply I'm going to go with the Superflower model, which is the Leadex 3 Gold HG series. It's 80+ gold certified and 550 watt, and it's fully modular. And in case you're interested, here's a quick rundown of the pricing. These are prices in US dollars, and these are the cost of the items when I purchased them. And the Silverstone case is $249. Obviously they provided this as a review sample, so I can deduct that from here. But as far as anybody wants to build a similar type of build, it's going to cost about $730 minus the hard drives. And I just went on Amazon real quick and added all the components to my cart just so we could get a sanity check here. So current pricing $249 for the case. Then I added all the other components to the cart as well. So you can see the grand total of all the components in my cart are $793.36 without even doing any shopping around. And that's for the CPU, the i3-14100, the Seasonic Focus GX650. Now I'm putting the Seasonic in here as opposed to the Superflower because the Superflower was not readily available. And then you've got the Western Digital SSD, the Crucial RAM, the Asrock motherboard, and the case as well. Now to build this thing, the only tools I should need should be a Phillips head screwdriver, maybe a smaller one as well, and everything else should just go in place. I'm going to start with the power supply, so I'm going to have to turn this guy over. There you can see we have a single 12-volt rail, 550 watt total for that. Okay, so we're going to need the CPU cable, power cable, a SATA power cable here because this has 3 on it. We only need 2 of those 3. And then a peripheral cable or the 4-pin Molex. And this has 2 on there. That's all we need for that. It actually has 4 on there, but I just need 2 of the 4. Line up that corner there, that right there. Then for the fan, you want to make sure that your routing is the way you want it before you put this down. And the CPU fan header is right there. Double check all your points have snapped in. Now when installing RAM, you have to make sure you install into the proper slots to get dual channel. And so if you look here, I don't know if you can see that here, but it goes A1, A2, B1, B2, and A1's closest to the CPU here. Then you look at the RAM configuration, and if you have 2 sticks, you need to put it in A2, B2 for optimal configuration. So we're going to go ahead and do that. So that means it would be the second one here and the last one here. When it comes to the NVMe SSD heatsink, always make sure that you check for any type of thermal pad because this has a protective piece of plastic over it that you need to remove before you install your M.2 SSD. Now, if you'll notice when I was installing this back plate here, there was quite a bit of flex in this spot right here. It'd be good if that was reinforced a little bit. I mean, it really shouldn't affect it overall, but it's just good to see a solid case, especially one of this cost. Now, the case does come with a number of different length screws, if you need them. Different heads too, but they're all Phillips. Some are rounded heads, some are flat heads. And also the key for the front of the case. Now when I opened this here and I was looking to install the motherboard, I noticed that it was missing a standoff here no big deal because they give you this little accessory bag here, and it comes with a standoff in it. Now it only comes with one standoff, which I find interesting, but either way, at least they provide it. I don't know why it wasn't included in here to begin with. They also give you this little tool, which allows you to put the standoff in there and then the Phillips head on top, so that way you can torque it down. Installing the motherboard, you could just slide it in here like this, and I was able to get it in there, but you're really better off removing the drive cage, which is really pretty straightforward, and I wouldn't recommend installing this with the drive cage in place. It just makes it more complicated, and you can't reach a screw that's down in the corner over here anyways. So to remove the drive cage, you just have the 1, 2, 3 screws here, and then on the front of the case you got a screw here and a screw here. Once you do that, and then with those 5 screws removed, all you have to do is pop it out like this. Now you'll notice this cable here to this fan is broken, and I don't know if that was my fault or if it came with a case like that. I don't remember it getting snagged when I removed this from the case the first time, but either way I contacted Silverstone and they did send me a replacement fan, so I'm going to swap that out real quick here. So the fan that goes in there is the Air Slimmer 90. This is what they sent me, and it's this thinner profile fan. So 92 millimeter by 15 millimeter. And unfortunately, it seems in order to swap out the fan, you have to remove the back plane here. I don't see any other way to do this. Now it does look like the back plane is actually 2 separate circuit boards, so I should be able to just remove the top one and not have to get this panel out of there. There's 6 total screws holding that back plane down. Assuming I can just now, there we go. This just removes like that. The fan is plugged into the board. Probably should remove that first. There we go. And then there we go. Circuit board comes right out. Pretty easy. And the fan does come, of course, with a fresh set of screws. It is nice to see that the length of this cable, though, is just taut enough so that it connects right here, so you don't have any loose wires that you have to manage. So I've installed and removed this drive cage several times, and you can see it's actually wearing on that wire there, and I can't quite see where it's snagging in there. So that's something that Silverstone might want to address, a way to lock this down. For the time being, I'm just going to put some electrical tape over it to make sure it doesn't break like the other one did. Alright, so I had to trim a piece of electrical tape lengthwise because the width I had didn't work too well, so I'm going to try to just secure this down like this. Probably be the best interim solution here. Now one thing that I noticed is installing the 24-pin power connector here. If we go like this, approach it from this side, and then this has to wrap over above the power supply when we put in the drive cage. So it kind of is a hard interference there. Now you see here, it fits, but I don't like that it has to bend so hard to a right angle and run over your motherboard and your RAM there. However, if I remove this and route it from behind, it's too close to this grommet here to really make it reasonable to install this, and leaving enough room for the drive cage to go in place. Now the only thing I could think of short term here is to use a right angle power adapter. I'm not a real big fan of adapters and extensions just because it's another point of failure typically, especially for your 24-pin main. You want to make sure it's a high quality adapter, and unfortunately there's not a lot of choices out there, or you get a bunch of cheaply made parts out there, so you're never really sure what you're going to get. So, but I did find this one. This one is actually just something I found off of Amazon, so I'm hoping for the best here. Now, I'm not sure exactly what Silverstone could do in this case, but I did notice that most micro ATX boards do have the 24-pin power connector right here, and so it's kind of a pinch point in general for attaching this cable or connector. Well, this is the lowest profile adapter I could find, and even when I plug this into here, this sits higher than this opening here, so there's no way I could just run the power connector straight this way without maybe even removing this protective grommet. See, there's no way that you can actually connect it that direction either, so your only option really is to run it over your RAM and in here and run it at a 90-degree angle. Now for USB cables that go to the front connectors, it comes with the USB 3.0 20-pin connector that you're probably used to seeing, but also this, I think it's called a Type E USB 3.2 connector. And in this case, this motherboard actually supports both. So this runs to the Type C connector, and this other one runs to the Type A connectors on the front of the case. So this is where I have concerns, right? When sliding this in, you've got these cables here. In my opinion, if this case was just a few millimeters wider, you could accommodate for a right angle 24-pin adapter, and also less likely to having to bend some of these cables excessively when you slide in the drive cage. Now one thing is with the SATA cables I noticed is this top one is no problem at all. But when you come down to this guy here, one, this isn't necessarily an issue of the case, but you actually have to pass over the fan to connect it here if you're going to use the same connector. If I do get this in here, it's here that it's bending that SATA connector awfully tight there too. Not the end of the world, so extensions might be a good idea, or running separate cables across. It'd be nice if this connector was actually on the other side. So you really need a connector with wires that come out the back to prevent that. It's not the end of the world, but I just don't like seeing things under tension like that if they don't have to be. So to mitigate that, I have these SATA power extension cables, and I'm going to see if I can't route that and make that a little bit better. And so you notice that it actually comes out of the wires come out of the back like that. There we go. Not the prettiest, but it'll have to do. I got the SATA power connectors connected to some SATA power extensions, and then also I just went direct to the 4-pin Molex directly to the power supply. Those actually were able to route pretty decently. So this is your typical SAS to 4SATA port breakout cable, and I have two of them connected to this LSI SAS adapter, so that way we can support all 8 disks that are in this drive cage. And this is the only way I could see to really cleanly route the cables, because the SATA ports are over on this side. There's no way to pass them back to the back and run them cleanly over to here. The one thing I'm not real comfortable with, if you look here, is these lower 4 ports. I kind of have to bend the cables kind of precariously here, and I'm not comfortable with that, as far as don't want to cause problems with the data transfer. So this is something that you might want to consider using right angle connectors for, and I'm not sure if they make SAS to right angle SATA cables, but I'll have to take a look at that. And also the fact that they're on this side, these kind of have to sit out in space. There's no way to cleanly run them over to these connectors here, unless you pass them, I guess, through this 3.5-inch drive bay through here and then up and around somehow like that. But for now, this is the way I'm going to run it. And if I find a different way to do it, I'll show that later in the video. Now that we have everything hooked up, I'm going to go ahead and power it on, and we can evaluate it for fan noise and cooling performance, and if there's any other added vibrations or anything out of the ordinary there. Now I'm going to be using Open Media Vault, and I'm going to set these up in different RAID arrays so we can kind of evaluate the performance under load while building an array. While I typically use 2 terabyte hard drives to do my benchmarking with, I want to use these high capacity drives in this case to check for cooling performance overall, to be more realistic with what people might use this case for and the type of drives that they would use. So I've got a combination of disks here that are high capacity, 18 terabyte Western Digital white label, 18 terabyte Exos X18. I've got a couple of Iron Wolf Pro 18 terabyte drives here, and then I also have some white label Western Digital, a couple 14 terabyte, and then a couple of 12 terabyte right here. Now these drive cages are actually pretty nice. They come with the little side snap-in rails here, And so you just drop your drive into here. Make sure that you line up the holes. And then the important thing is to make sure that you have this little tab here. So it's got a little tab at the end there. And that just tucks into this slot right there in the side rail there. Make sure you do that, otherwise it won't fit properly. There you go. Then you just take it and slide it right in. It's nice and snug in there. And then to remove it, squeeze both sides and it pulls right out. Now I thought I would mention, while these are fairly easy to slide in and out, I did have a couple of these and that the trays do tend to get stuck, and I have to literally reach in there to pull it out. Now one thing with these drive sleds that I noticed, I've got this 14 terabyte here and this 12 terabyte here, okay? And if I put the 14 terabyte in this location, when you go to pull it out, it's really hard to pull out. Put it in the slot below it. Same thing, it's difficult to pull out. I take this 12 terabyte, right, and I put this in that same spot. Squeeze it, pulls right out. Same thing with the second spot. Not a problem. So it seems like some drives have an issue with being stuck inside the drive tray here. Now I'm going to swap the drive tray. I'm going to use the 12 terabyte drive tray on this 14 terabyte to see if it fixes it. Go ahead and plug it in here. Pull it out, still stuck. This bay here. Still stuck. Now we take the 12 terabyte that is in the same sled that the 14 terabyte was in that was having problems. Plug it in, locks in place, comes out just fine. So I'm not sure what to make of it. I've got two drives that seem to have that issue. Now I'm not certain that it's necessarily the drive sled issue, but I don't know what else it could be, because these disks are to a standard, right? So, and it's weird that it does just affect a couple of disks, but maybe there's something there. But either way, it's a little frustrating when you want to go pull out some drives and they don't even come out at all. You have to reach under there, move the drives beneath it, so you can actually get underneath there and get some more torque on it to get it out. Alright, I disconnected the hard drives and also pulled out the LSI card because I just want to get a feel for how the fans are, and I'm going to go ahead and power it on now. All I have is the CPU fan, the case fan, and then the two fans that came with the drive cage here. Yeah, that's pretty loud. Seems all that noise is coming from these fans in here. I stopped those. That's the fan noise. It's basically gone. Alright, just to get an idea for the sound using this decibel meter here, I'm going to let it idle for a few seconds here. I'll probably speed up the video just to give it time to equalize, and then I'll go ahead and start it up. You get an idea for the fan noise as far as the decibel reading is concerned. Now, to be fair, that was with the side panels off. Not that these will probably make much of a difference. Those fans are pretty loud, but we'll give this a shot here. So you can see here I've got all the 8 discs installed in here, and I put all the panels on it. And the fans, you can hear them running full speed. And I'm going to go ahead and do some testing within Open Media Vault. Now one thing while this is booting, you cannot put anything in these USB ports if you want to close this front panel, like this USB dongle for a keyboard and mouse. I put this in here. It's not real thick, but you can't close the port here. So if you want to use USB ports, really it's there when you have the panel open. So you're going to have to resort to some other means. So here we are in Open Media Vault 7. This is the dashboard here, and you can see disk temperature information here. And we go over to storage. We can take a look at the smart data for each of the devices. You can see we've got the different hard drives that I showed you earlier in here already. Get a better distribution here. Disks SD, A, B, C, D, E, F, G, and H. Those are the between 18 terabyte and 12 terabytes in size. And I'm going to run these in a RAID 6, so that way it should stress the disks for an extended period and kind of get an idea for how the temperature is affected. And the fans are currently set to full speed because you don't have any control over that. And so I guess we'll see how it fares. All right, I've decided to plug the fans into this Y adapter to a fan header on the motherboard. And this case is chassis fan 1 on the motherboard. And I currently have it set to full speed. And I'm going to try to get the audio down a little bit. So I'm going to set that to performance mode. And you can instantly hear the noise go down. So I'm going to do another temperature test at that setting and see how it goes. So I'm going to swap out the stock fans with this Thermalright TL9015B fan. It's also a thin profile fan, and it's supposed to have higher CFM, but it has a lower static pressure, but it's also supposed to be significantly quieter. So we'll see how that goes. So here's the Thermalright fan here, and I'm going to go ahead and plug it in just so we can get an idea for the sound. So here are the cooling performance benchmarks, and what you see here are the stock fans running at full speed because they're plugged in the back of the backplane. And at the top forward edge of the case, that's about the decibel level that you would get from them. What you see here in the different colors represent the different hard drives and the different slots. Slot 1 is starting at the top, and slot 8 is all the way at the bottom. So what I did is I ran a RAID 6 build so that I could stress the disks and check the resultant temperatures throughout that build. Now I only ran it for like 2.5 hours. To do an entire RAID 6 build with these capacity disks would take a full day. Then once it finished the RAID build, or at least I stopped the RAID build, I shut down the machine, I double checked the serial numbers versus the bays that they were in. And because I did that in the first test, I ended up doing that on subsequent tests just to be consistent. So I shut it down for about 10 minutes, booted it back up, and then monitored the disks just at idle, not running a RAID build. And here's the results here. So you can see the fans running at full speed. They did hit at max about 52 Celsius, but all the way down to about 44 degrees Celsius on the slot 2 drive. Then at idle ranged anywhere from 39, 38 degrees all the way up to 47, 48 degrees. I then took the stock fans, unplugged them from that backplane, and plugged them directly into the motherboard. And I went into the BIOS and set it to what they had was a performance setting, which was just one step down from maximum speed. And again, I ran the MDadmin RAID 6 build, turned it off, started it back up, made sure that the disks were at idle, then recorded the temperatures again. And you can see here during the RAID build with the fans in the performance mode, it just wasn't adequate enough. It hit that 60 degrees Celsius threshold, which really I think disks should remain below 50 degrees Celsius if you can help it, because specs typically call between 55 to 60 Celsius as the ceiling for running disks in production. In any case, I would avoid running at anything less than full speed based on these results. And even once I ran them at idle, it did end up cooling off a little bit and getting it down below 60. But again, the highest temperature was still about 57, 58 Celsius even at idle. So then I swapped out the stock fans with this Thermalright fan, which is supposed to be a quieter and higher performing fan. And here are the results here. Here's the full speed results. And the RAID 6 build, it did not exceed 40, let's just call that 45, 46 Celsius. And then once I stopped the RAID build and went to idle, you can see here temperatures dropped by maybe a few degrees Celsius. But in any case, it did maintain the disks well under 50 degrees, either at load or at idle. And then I did the same thing as I did with the stock fans. I plugged them into the motherboard and set it to the performance setting. And here are the results here. You can see that they did not exceed 52, 53 Celsius even at load. And then once I put them to idle. They only dropped a few degrees Celsius, but tended to hover right around the 50 Celsius mark. Now, if you want to do a direct comparison between the two sets of fans, the stock fans and the thermal right fans that I put in there, here they are running at full speed. The orange represents the thermal right, the pink represents the stock fan. The dot is the average temperature of all the discs at that point in time, and then these tick marks at the top and bottom are the range minimum and maximum temperatures. So you can see here that the thermal right fan with the fan set to full still performed considerably better than the stock fans, and it did run a little bit quieter too. And then once it went to idle, over time they ended up running at about the same temperature in the low 40s. Now when I sent the fans to performance mode connected to the motherboard, you can see the difference here. We hit maybe about 52 Celsius on the thermal right fan, but again, we hit about 60 Celsius on the stock fan on average, and we actually, couple of the discs went up to 62, 63 Celsius, which is not good. And then once I put it to idle again, you can see the fan curve here. So what does this all mean? Effectively, to me, it means that the stock fans are adequate if you leave them at full speed, except they're loud. So if you want to improve on that, there are options, and the chances are the option is going to be to swap out the fan altogether for a different one. Because even running those stock fans at a lower speed, it made the temperatures go way above what they should be. And I'm currently using all SATA drives in there at the moment, right? You're probably familiar with that connector, the separate power and then data cable, whereas SAS is all one connector and one power and data. I'm going to go ahead and plug in these couple of these SAS drives just to make sure that these pass through fine if you want to use any SAS drives in there. So I plugged in those two HGST SAS drives, one in each backplane. You can see that they're clearly detected here in Open Media Vault. So if you want to use SAS drives, that backplane will accommodate them. Now, since this case does offer some expansion options, I thought I'd throw in a few extras here. One is this 5¼ inch bay adapter for a 3½ inch and 2½ inch disc, and I'm going to put that in the 5¼ inch bay on top. Then I've got this slimline DVD-RW. Don't even know if it works, but as far as getting it installed, it should serve the purpose, and see how that goes. And then for the lower drive cage, I've got an extra hard drive here. I'm going to throw that in there too, as well as a couple of Samsung SATA SSDs on that back plate that's on the back of the motherboard. Well, the optical bay opening is apparently for 9.5mm, and this is like a 13mm thick optical drive, so I can't try that out. Now I will install these two 2.5 inch SSDs to this back plate here. And the case does provide screws to mount these SSDs. Just as a side note, I saw in the manual that you can't install a top water cooling radiator if you utilize this 5¼ inch bay. So on this side, they only have the one screw mount for you. You can't screw it in back here, but it seems secure nevertheless. And you can see the provisions here on top of the case. It does have the screw downs for a top-mounted water-cooled radiator if you wanted to add it. It should support up to the 240 or 280mm ones. So to mount a hard drive in the lower drive bay here, you really have to, well, you can fit it in here. You can't access the screws on the side to mount it. So you really got to take this bracket off. Now I was able to get this 3.5 inch hard drive in here, but now I can't get it back out. The only way to, I don't know how that works, but in order to get it out, I need to actually remove this bracket, which means I need to flip the case upside down so I can access the 4 screws that are underneath, and these 2 screws right here, and I think there's a couple screws on the other side too, and this bracket should come right out. But before you do that, you actually have to remove the whole drive cage too. So kind of a pain in the butt to access this. So if you ever do use it, I guess hopefully it's a disc that you put in there that you don't need to swap out occasionally. So there's the 4 screws. And these 2 screws here. And then 1 screw on this side, actually, not 2. So yeah, this whole drive cage does have to come out. And the holes are designed to have the disc in this orientation here with the cables out the back. So it'll be coming out this side of the case. Now if you look at that profile, you can see that there's not much of a gap between this bracket and the hard drive. And I'm surprised that they didn't lower this down maybe a little bit more, just so that we could get some even airflow across the top and the bottom of the drive. And in case you're wondering about drive temps for that lower fixed bay, this is just a 2 terabyte hard drive, and I did use a thermal right fan using the performance setting. You can see here I ran it through a disk wipe, so it stressed the disk and it only went up to about 44 degrees Celsius. And then after it completed, at idle temperature, it hovered at around 40 Celsius. That's a bit surprising considering the location. It's that lower spot where there's really no airflow, but nevertheless, that's the results. Sorry for such a long video, but I thought it would be interesting for users to see components being built up in this NAS case. And also for those that are not familiar with a NAS or are hesitant to build up their own, they can see building up a NAS is really no different than building a basic PC. You just need a motherboard, CPU, RAM, boot drive, power supply, and of course a way to hook up a bunch of hard drives. It's also nice to have hot swap bays for easy drive addition and replacement. Now this Silverstone CS382 case is a good option for supporting 8 hot swap drives in addition to 2 more 3.5 inch and 2 2.5 inch drives, but they're in fixed locations. And then also has support for micro ATX and mini ATX motherboards and ATX power supplies. So to summarize, rather than add 10 more minutes to this video of me yapping, here's a list of things I liked, but also a list of things that I feel could change or be improved to the CS382. So I'll just leave this up here so you can read it yourself and or look for the specific location of the video, as I believe I addressed most of these points earlier in the video in more detail. So I hope you found this all interesting and helpful, and until next time, talk to you later.